Yeah, so I'll be talking about rest assured APIs. That's just like a form. It's majorly how to write APIs that you yourself can understand and you won't have a lot of issues while writing the APIs. So the first thing to do when you are writing your API is to like strategize or write out your DP, how your DP, the flow of your DP. Then the first step in creating any sort of application is creating the database. You need a vague idea of how your data is going to be stored. So for relational databases, it's very likely you will start off your planning with entity relationship diagrams. So show the relationship between maybe your tables. And for MongoDB, CoreDB, and Elasticsearch, you can let your application create the schema for you. Just have a sketch of what your DB is going to be like before you start writing the application. Because by the time you start writing, before you go back to the structure of your DB, you might actually have to rewrite some things and not really like what you have done, and it takes longer time. So there are seeders. So since we have an existing database schema, you can store your data, and you won't be advised to use real data. So it's best to have dummy data in your DB. So having real data in cases where you want to test and you really don't want to delete, but you have to delete maybe by mistake or something, you won't have much to lose. It's just dummy data. So there are some libraries available across various languages for generating dummy data, and we have fakers for Python, we have fakers for PHP. So these dummy data could be generated, and you can add them to the DB even before you start building your application. So the next thing you might want to do after you've already seeded your DB is planning and creating your endpoint. So you might want to work out the requirement for your API. So you try thinking about everything you need to handle. So basically is usually called apps that work, and so you can talk to in cases when you are the one working on the project or just you and somebody when it's not like a large scale team. You might want to speak to your mobile app developer or your front end JS developer before you get started. So there are other possible variations of the product. We have the bread, which is browse, read, edit, add, delete. The div, delete, add, view, edit, crab, and chrome E. So at this point, it's very necessary to know which action is best for whatever request you're about to make. So for the best method for whatever request you have to make, it's also good to plan that. So we have the get, the post, and the like. So let's talk about this. So you use get request to retrieve resource representation information that you might not need to modify in any way. So get request do not change the state of the resource; they are set to the same methods. So like it's best to use get methods for in a situation where you will not need to modify the resource you are fetching in any way. So then their get requests are set to be idempotent, and that's like you can make multiple identical requests and it will have the same effect except that the response will be different compared to post request. So you can, yeah. So for post request, you use post to create new subordinate resources. Subordinate resources that is like simpler forms of a particular resources. So like if you want to create a new you want to append a new row to a particular table, it's best to use post request. And post request, they are not idempotent compared to the get request. So two identical post requests will result in two different resources containing the same information. So put. So we also have the put ATC being for method. So they are used to update existing resources. Like you have an existing resource in the DB, you want to update that. They are used to update that. And so if you use puts also, like you can use puts to also, like maybe you've never even added it to the DB, you can check if it already exists. If it is not existing, it's puts a new one. If it is existing, it replaces the one there with the new one. So the delete, as the name implies, delete APIs are used to delete resources. So yeah, so delete a successful response of delete request should be ATC response of 200. That's ODOK response code. So if um, the response includes an entity describing the status, 202 is the response code, and if the action has been queued, or so for if the action has been performed, but the response does not include an entity, they're just response code. So delete operations are idempotent. That is just like we talked about what idempotent operations are. So a delete resource, if you delete the resource, it's removed from the collection of resources. Repeatedly calling delete API on that resource will not change the outcome. So however, calling delete on a resource the second time will return a 404 because it couldn't find the particular resource you were trying to delete. So we have patch. So there's a difference between patch and put actually, but they are quite identical. So patch requests are used to make partial updates on the resource. So they are not planned. They are not you perhaps you want to like update a part of a particular resource. Say there's a row, you want to update only one resource in that particular row. You're not trying to update everything. So in patch, you don't need to provide all the resources of that row before you can update it. You just need the particular one you need to update before you can update it. Then another thing that I want to talk about is knowing the right status code and error messages, so you don't get things mixed up and get confused. So it's good to know your status code. So status codes are used in all responses and they range from 200 to 507. And yeah, so talking about the 200s and status codes, so they are all about success. They are used to show maybe a particular request was successful. So whenever a client tries to do something and it's successful, the response codes are. So whenever you have the 202, it doesn't necessarily mean that whatever you're trying to do has been completed. It just shows that it has been accepted. So it only indicate that a request has been accepted and is being processed synchronously. So for the 300s, they are all about redirections. So they are about sending and calling applications somewhere. These are all about sending the calling application somewhere else for the actual resource. The best known of these are the 303. Then there is 301, which means move permanently, which are used a lot on the web direct browser to another URL. So that's most of the time people don't really like use the 300 status code for any request that maybe has to do with something being moved, which is 301 that should have been used. People just end up using 404 that is not there, but it's actually been moved. It was actually there before. So for the 400s, they're all about the client errors. So they're like from the client side, they are caused by maybe fault on the part of the client. So this status code include that the client has done something invalid and needs to fix the request before he sends it. So an example is 404. You on the part of the client, you know what you are trying to the resource you are trying to access is doesn't exist. So an example is 404, which is the most popular status code. So for the 500s, they are actually the I would say they are very challenging for me because you sometimes don't know what the actual situation is. There are service errors because this status code they indicate that something went wrong in the service. For example, a database connection failed. Typically, a client application can retry the request. The server can even specify when the client is allowed to retry the command using the retry after HTTP header. So, my references are from build APIs you won't by if you study and RESTful API.net. Thank you.
Any questions, comments? Should comments go live? Any questions? No questions. Okay. Okay. So I think we'll be ending the broadcast.